Click the bell icon to get latest videos from Ekeeda.
Hello friends, in this video we are going to continue one more problem on definite integration. Let us start with problem number 12. Integral 0 to 1 x cube tan inverse x dx. Now you can see friends, we can solve this integral using UV rule. The first function is the algebraic function and the second function is the inverse function. In the word Lyot, you can see that inverse function should be followed by a algebraic function. Therefore, in this case, we need to reshuffle these functions. I will be 0 to 1 tan inverse x into x cube dx. Considering first function as u and second function as v, we will expand this using integral u v dx from a to b. That gives you u integral v dx from a to b minus integral of a to b d by dx of u integral of v dx the whole dx. Therefore, I is equal to u, that is tan inverse x. We have integral of x cube dx. The limits are 0 to 1 minus 0 to 1 d by dx of tan inverse of x into integral of x cube dx the whole dx. This will give you I is equal to tan inverse x integral of x cube is x raised to 4 upon 4 within limit 0 to 1 minus we have 0 to 1 derivative of tan inverse x is 1 upon 1 plus x square into integral of x cube will be x raised to 4 upon 4 the whole dx. In the next step, we can take this 4 common outside the integral. Therefore, I is equal to x raised to 4 tan inverse x upon 4 within limit 0 to 1 minus integral 0 to 1 we have 1 upon 1 plus x square into x raised to 4 dx. As you can see in the second integral, we have x raised to 4 in the numerator whose power is bigger as compared to denominator. Therefore, we must divide these two equations. Considering this as equation number 1, let us start dividing these two functions. X raised to 4 divided by x square plus 1. If I divide first term by first term, that is x raised to 4 upon x square, we have x square left. And multiply it again, x square into x square is x raised to 4 plus 1 into x square is plus x square. On further solving, changing the sign of the second equation, x raised to 4 will be cancelled and we have minus x square left. If we further divide minus x square upon x square, this will give you minus 1. So x square into minus 1 is minus x square and plus 1 into minus 1 is minus 1. This will give you plus x square and plus 1. X square will be cancelled and plus 1 is the remainder. This is our dividend. X square plus 1 becomes divisor, while this is our quotient. Therefore, we can write the dividend x raised to 4 as divisor into quotient plus remainder. Also, you can consider this integral as I1. So, I1 will be equal to integral 0 to 1 x raised to 4 upon x square plus 1 dx. That can be further written as 0 to 1 x raised to 4, that is our dividend, will be written as x square plus 1 into x square minus 1 plus remainder is plus 1 divided by x square plus 1 dx as it is. Now we can separate this x square plus 1 to both the terms present in the numerator. I1 will be equal to integral 0 to 1 plus 1 upon x square plus 1 dx. Here x square plus 1 will be cancelled and I1 is equal to, on separating integrals we have 0 to 1 x square dx minus we have 0 to 1 1 dx and plus 0 to 1 1 upon x square plus 1 dx. Thus we can substitute the value of I1 now in equation number 1. This will give you I is equal to x raised to 4 tan inverse x upon 4 within limits 0 to 1 minus 1 by 4. The value of I1 is integral 0 to 1 x square dx minus integral 0 to 1 1 dx plus integral 0 to 1 1 upon x square plus 1 dx. Now you can multiply this minus 1 by 4 to all the three terms present inside the bracket. This will give you x raised to 4 tan inverse x upon 4 from 0 to 1. We have minus 1 upon 4 integral 0 to 1 x square dx. Minus into minus will give you plus 1 upon 4 integral 0 to 1 dx. Minus into plus will again give you minus 1 upon 4 integral 0 to 1 1 upon x square plus 1 dx. Therefore I will be x raised to 4 tan inverse x upon 4 from 0 to 1 minus 1 upon 4 integration of x square will be x raised to 3 upon 3 plus 1 upon 4 integration of dx is x minus 1 upon 4 integral 1 upon 1 plus x square will give you tan inverse x. Now let us substitute both the limits. This will give you, substituting upper limit x as 1 raised to 4 is 1 upon 4 tan inverse of 1 is pi by 4. If you substitute x as 0, the entire part becomes 0. Minus 1 by 4. If I put x as 1, this will give you 1 by 3 and 0 will give you 0 only. Plus 1 by 4, this will give you 1 minus 0 and minus 1 by 4. Tan inverse of 1 is again pi by 4 and tan inverse of 0 is 0. Therefore, further we have 1 into pi is pi upon 4 into 4 is 16 minus 1 by 4 into 1 by 3 is 1 by 12. Minus into minus is plus 0. Plus we have 1 by 4 into 1 is plus 1 by 4 minus 0 minus 1 into pi is pi upon 4 into 4 will give you 16 minus into minus is plus 0. Here you can see pi by 16 minus pi by 16 will be cancelled and the remaining part will be minus 1 by 12 plus 1 by 4, which can be solved by LCM method. Taking 12 as a LCM, we can multiply this both by 3. This will give you minus 1 plus 3 upon 12, which is equal to 2 upon 12, that is 1 by 6. Therefore I is equal to 1 by 6 is the final answer. I hope friends you have understood this problem. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.